All right, part C. Coming back, tying it all together. Rational functions, vertical asymptotes, holes, all the shebang. In limits, everything. Here we go. We're geniuses now. We can do this easily in our eyes, in our minds, with our eyes closed. I need to close my eyes. I need to close my eyes. All right, here we go. So we have example number 6, example A. X plus 3 squared times x minus 2 over x plus 3 cubed times x plus 5. Will this function have a whole? Yes or no? Why not? Because what? The denominator power is bigger. So none. And that's because the denominator power is bigger. So I'm still left with the factor in the denominator. Agreed? Okay. So where do I have a 0 at? Where do I have a 0 at? At positive 2. I have a 0 at x equals 2 because your 0 is based off of your numerator. Now, where are my vertical asymptotes at? There we go. All right, we're going to keep going. Are we good? Okay, on to the next one. Do I have a hole? Yes. Why do I have a hole? The numerator is bigger. Does that make sense? Okay. So pew, pew. Oh. So this time we have a hole, and that hole is at x equals negative 2. Do I have a 0? No. And then the horizontal asymptote is where? Is at 3. Okay. Yes. Oh no, it's not factored in the denominator. What do? We factor it. We get x squared minus 9, which becomes x minus 3 times x plus 3. That's your actual denominator. It's 2x squared. There's no factoring. All right. Is there a hole? Yeah. Where is it the hole at? X. X. 0. It's at 0. The hole's at 0 because I crossed out the x and there's still an x left in the numerator. Okay, therefore, do I have a 0? No. None. And then what about my vertical asymptote? Yes. How many? Negative 5. Positive 3 and negative 3. There we go. Next one. Oh no, we're not factored. What do? We factor. What multiplies to give me negative 25, but adds to give me 0? Positive 5 and negative 5. What multiplies to give me 30, but adds to give me 11? 6 and 5. All right, here we go. Hole, where? Negative 5. 0. Incorrect. Where's my 0 at? Positive 5. Because when I cross this set, who was still left up there? It's friend. It's Flynn. And then what about vertical asymptote? At x equals 6. Negative 6. Perfect. Was that too fast? Wasn't even in here. You weren't even in here. You're not even in this class. Okay, for the ones who are actually in this class, how do we feel about holes, zeros, and vertical asymptotes? Better? Yes. Hole, 0, vertical asymptotes? All right. Okay, the other part now is just make sure we're comfortable with the limit. This is just reiterating to you how to find the y value of the, you can read it later. We don't need it right now. Um, so here it says consider that the x-coordinate of the whole, then use limits to find the y value of the whole. Okay, so I have the x-coordinate. I'm going to find the whole. So where's my whole at? My whole's at x equals 1. Agree? When I remove that, I'm now left with what? That, right? So we're now going to look for the limit. So the limit as x goes to 1, that means that I'm going to plug in to f of x 1. 2 times 1 over 1 plus 1 equals what? 2 over 2, which is 1. So therefore our limit is 1. So then and therefore our whole is at 1 comma 1. I don't think I need to do them all, but do you see how we find the whole? We eliminate and then we plug into what's remaining. Yes? Yes? Anyone needs another example of eliminating and plugging in? Oh, I got a yes. All right, here we go. On this one, x plus 4 is eliminated, which means it's at x equals -4. So we're going to plug into what's left. So to find the limit, it's going to plug into g of x, 4 into g of x, -4 into g of x. Gives me -4 minus 3 over -4 plus 2, which gives me -7, right? -7 over -2, which is just 7 over 2. Yes? Max now? Makes sense? All right, so we can all find a whole. All right. I did get here to just go over limits, how to read limits to know what you're looking for. All right, so the first thing it says that we have limit as x goes to 2 from the left, it's going towards 3. Limit as x goes 2 from the right, it's also going towards 3. So what does that tell me about this function? So that there's a hole possibly, right? There's a hole at 2 and it equals 3. Does that make sense? So there's a hole at 2. So we have a hole at 2, and the value of that hole has to be 3. Okay, the next thing it tells me the limit as x comes from the left of -4 is -infinity, and the limit as x goes to -4 from the right goes to positive infinity. So this tells me that I have a vertical asymptote. So I know that I need to have x minus 2 in the numerator and in the denominator. And because I have a vertical asymptote at -4, I need to have x plus 4 also in the denominator. So that's so far. So I've handled the vertical asymptote, but I need to make sure that the exact value is 3. When I eliminate x minus 2 over x minus 2, this is where the math comes into, like the math sense comes into play. What would have to be my coefficient? What would my coefficient have to be in order for this to be true? Huh? Mm-mm. I need this to equal 3 when I plug in 2. So here we go. So if we have R of 2 equals, and we're left with C over X plus 4, and we need it to equal 3. Well, we know that X is 2. So C would have to be 18. Because if it's not, will it satisfy the fact that the whole is approaching 3? So now we know the value of C is 18. Okay, we're running out of time, or I was going to have you guys do the next one, but we're out of time. We're out of time. Help me. All right, so over here, we know that we have a whole at -1. So at -1, it's going to 2. So this is a whole at x equals -1. Here we have the limit as g of x goes to 3 from the left, it's positive infinity. And the limit as g of x goes as 3, limit as x goes to 3 from the right of g of x, it's positive. It's positive infinity. So this lets us know that we have a vertical asymptote. And it's a vertical asymptote with an even degree. The reason why it's an even degree is because my end behaviors are doing the same thing, even behaviors, okay? So plug in what we know. We have r of x equals, currently do not know our leading coefficient here. We know that in our numerator and denominator, we have to have x plus 1, okay? Because that's where our limit is. Then our limit was approaching our whole is at -1, so the factor has to be x plus 1. And then we're going towards 3. So we have a vertical asymptote at 3, which means that the factor has to be x minus 3. And because your end behaviors are doing the same behavior, it's going to be at least squared. Okay. So now we got to find the value of our c. So to find the value of our c, we know the value once we eliminate. So we're going to be using modified, right? So we know that when r of, I don't know why I did that again. When r of -1, it equals 2 for c over -1 minus 3 squared. Okay, notice I didn't use the x plus 1 because those are eliminated. Those are the whole values. So they are eliminated. So we go through the math and we end up with -1 minus 3 is 4. 4 squared is 16. So we have 16c. So the only value that c could be is 32. So we get c equals 32. So therefore, our function is 32 x plus 1 over, yes, x plus 1 times x minus 3 squared. Okay, so the rest of the problems are just more practice. So if you go on to the next one, it's just completely practicing everything, like putting it all together. So from top to bottom, making sure we can put it in its simplest form, making sure we understand what we're left with. So in the simplest form, we would eliminate x minus 3 over x minus 3. So we would have that our rational function that we're left with would be 3x minus 13 over x minus 2. Okay. Then the coordinates of our whole, so using our rational function that we're left with, our whole, so we had a whole at x equals 3. So r of 3 equals 3 times 3 minus 13 over 3 minus 2. So 9 minus 13 over 1 equals -4. So we'll be at -4. Our domain, so going back to reading domain, reading our graph from left to right, we have a vertical asymptote. Pretend that's a straight vertical asymptote. So reading our graph from left to right, we go from -infinity until we hit +2, not -2. I'm just going to go to +2. And then we have a pause because we have a hole. We have a hole here at 3. So we'll go from 2 to 3 because that's where our hole is. And then from our hole, we go from 3 to infinity. Okay. Range is bottom to top. So working our way from the bottom, we're heading negative infinity. And oh no, there's a hole. So we go from negative infinity to -4, pause, and then we get back on the train, do. And we're like, oh no, there's a horizontal asymptote. So then we're at -4 to +3, pause, and then, okay, and then we continue on our journey from 3 to infinity. Okay, this is because we have a vertical asymptote at x equals 2. We have a horizontal asymptote at y equals 3. Okay, so looking at all this in terms of a limit. So in terms of a limit, the limit as x goes to negative infinity of f of x is approaching 3. And that's because we have a horizontal asymptote. The limit as x approaches 2 from the left, so 2 from the left, there's a vertical asymptote stopping us and causing us to go towards positive infinity. The limit as x goes to 3 in general, so as x is going to 3, that's our whole, it's -4. The limit as x goes to infinity, so as x goes to infinity, it is also approaching 3. And the limit as x goes to 2 from the right, it is approaching negative infinity. And that concludes all of Unit 1B.